All right, hi students, this is Miss Medina and I'm gonna quickly go over the study guide. Let me know if you have any questions, okay? So for the first part on radicals, you need to make sure that you can recognize your perfect squares. And so your perfect squares are gonna be 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225, and they go on, okay? So please make sure that you can recognize them. And then how to find factors of your biggest perfect square. So 12, yes, you can break up 12 in many different ways, but remember we're looking so that one of the factors is a perfect square. So we can break this off into the square root of 4 times the square root of 3. And so the square root of 4 is 2, so this becomes 2 radical 3. 48. 48, let's see, divided by 4, yes. But when I divide by 4, I get a 12. And I know that 12 also has a 4 in it, so I'm going to try 16. 48 divided by 16 is 3. So then the square root of 16 times the square root of 3. And the square root of 16 is 4, so this is 4 radical 3. Square root of 18 is going to be the square root of 9 times the square root of 2. Square root of 9 becomes a 3, so this is 3 radical 2. Square root of 40, 4 times 10. Yes, because 10 is 5 times 2. So this is the square root of 4 times the square root of 10. Square root of 4 is 2, so this becomes 2 radical 10. Square root of 25 is a perfect square, so this is just 5. Finding the perimeters in areas with radicals. The perimeter, that means you need to add all the sides. And so in adding all the sides, the perimeter for a rectangle is twice the length plus twice the width. So it'll be 2 times radical 5, right? We're assuming the length is radical 5. And the width can be that one. Plus 2 times 3 radical 10. All right, let's clean that up a little bit. 2 radical 5 plus 2 times 3 is 6, so that's 6 radical 10. All right, so the first thing to notice is that this radical here is not the same as this one. And can we simplify it? I don't think we can, because 10 is just 10 times 1, 5 times 2, and none of those are perfect squares. So no, so this is the perimeter. All right, the area. The area is the length times the width. So in this case, we have to do radical 5 times 3 radical 10. And so the outside with the outside and the inside with the inside. So this becomes 3 radical 50. And the 50 came by multiplying the 5 times 10. Can we simplify the 50? Let's see. Oh, yeah, the 50 is 25 times 2. So this becomes 3 times radical 25 times radical 2. All right, the radical 25 is going to become a 5, right? So this is 3 times 5. And the final cleanup will be that A equals 15 radical 2. All right, 3 times 5 is 15. All right, rational irrationals, please make sure that you can classify them as your integers, your ratios, repeating decimals, terminating decimals, perfect squares, the square roots of perfect numbers, which are rational, and then you have your irrationals, never end, never repeat, perfect squares. So individually, you should be able to look at them and determine what do you have. This is negative 12, and this one is rational. I mean, technically speaking, negative 12 is negative 1 times 12, right? And they're both rationals, which is why you get rational. Radical 6 is not, 6 is not a perfect square, so it's I, 2 over 3. Now, if you think about it, every fraction is technically a rational number divided by a rational number, which is why you always get, which is why they're considered rationals, okay? Square root of 25, so even though it's a radical sign, you need to determine, hey, is this a perfect square? Yes, it is. Okay, there we go. Why? Because this equals 5, and 5 is rational. Pi, so just because you see pi, remember, don't assume that it is automatically irrational. Any number divided by itself is 1, and 1 is pretty rational. Radical 3 divided by radical 3 is a 1, so pretty rational. Square root of 81 over a square root of 100, yeah, they don't cancel, but they're perfect squares, so this is 9 over 10, which is R. Same thing in H. Just because you see a radical, don't automatically assume irrational, okay? This is 2 over 5, which is rational. They're perfect squares. Okay. So this now we're thinking a little bit more about the operations. If you have an operation between two rationals, always rational. I mean, unless this right here where I'm highlighted in yellow, I mean, your rational cannot be 0 when you're dividing. The denominator cannot be 0 when you're dividing because we can't divide by 0. So that would be the exception here. I was trying to figure out how to spell exception. All right, R plus I, any combination of rational and irrational. All right, so the few exceptions are going to be if your rational here in both of these cases, and this one, happens to be 0. Why? Because if it's 0, you get 0, and 0 is pretty R, so you wouldn't get an I. But besides that, any other value is good for this rule. And remember, we cannot divide by 0. It's not possible. Right? So, but other than that, as long as 0 is not involved, we're good. When you have two irrationals, you don't know what you're going to get. So you need to calculate. That's the only way to determine the answer, by doing the math. All right, so let's see. This one is a multiplication problem for A. So that means that we're going to get a product. All right, this product comes from a rational times an irrational, which means our answer is going to be irrational. B is from addition, so that means we're going to get a sum. This sum comes from two rationals, so that means we're going to get an R. This is multiplication, so that means we're going to get a product. Okay, this product comes from I times I. So there's no way to know the answer unless we actually do the math. So what's radical 7 times radical 7? All right, so radical 7 times radical 7 is square root of 49. Square root of 49 is perfect, so that gives us 7, and 7 is R. This is multiplication again, so we're going to get a product. So this is the product of a irrational times a rational, right? Pi times 2. And so the answer is going to be I. This is a subtraction, so this difference. The difference comes from pi minus pi, which is I minus I, right? But since they're both i's, we need to do the math. What's pi minus pi? 0. And 0, my dear students, is rational. Radical 3 over radical 3 is a division, so this is a quotient. So this quotient comes from dividing two irrational numbers. but what we get is determined by actually doing the math. Any number divided by itself is 1. So this is another case where two i's give you an r. All right. What would you measure with the following units? We did this in class, but millimeters is going to be when you're measuring something small. Gallons, like how much gas you put in a car. Miles, like distance between two towns. Meters, width of doors. Kilograms, weight of humans. Fluid ounces, doses of medicine, okay? So make sure you have a sense of the units. So we don't talk about a human being 4,000 kilograms. That's ridiculous. That's not the right unit. Carl is traveling at 70 miles per hour. Fill in the missing conversion factor to change to feet per second. All right, so let's look at what's already there. We know we start with 70 miles over 1 hour. A conversion is missing here, but then they did 1 hour over 60 minutes. That's to cancel the hours, okay? And then they did 1 minute over 60 seconds. All right, so seconds is what you want, so we're good. So the one that's missing is feet. Miles. What is it? 1 mile is 5,280 feet. Right? So now the miles cancel. And there you go, feet per second. So then you take all the numbers in the numerator. Over all the numbers in the denominator. All right, numerator 70 times 5,280 times 1 and times 1. I mean, really? If you want to multiply by 1, multiply by 1. Now the denominator, it's a 1 times a 1. And like I said, if you want to multiply by 1, knock yourself out. Just make sure you know how to use your calculator. And this is 60 times 60. So you got 2 of them. So this is the part where you have to do the math in your calculator to make sure that you're getting the same number. I can't make you practice, but if you do it correctly in the calculator, you're going to get, and I'm almost there, you'll get 308 divided by 3, which is meaningless for us here because nobody talks about feet per second and 308 divided by 3, but 102.6 feet per second, or 103 feet per second, however you want to look at it. All right, how many can you buy with 3,550? Well, you have $3,550, right? Right, and this is technically over 1. And we can buy 1 horse with $695. All right, so then ultimately the numerators are these and the denominators are these. All right, which is why you end up with 3,550. Okay, so why aren't you putting the times 1? What's 3,550 times 1? 3,550. And your denominator is $695. So this is why, right? The dollars cancel, and guess what you're left with? All right, so this is going to be about $5.1 or 5 horses, okay? All right, same thing here for the goats. You have $3,550. right? And you know that each goat is going to cost you 200. So notice that we put the goat on the numerator and the 200 in the bottom. Why? Because it's the only way for the units to cancel and change into goats, people. All right, so now to collect your numbers, the numerators, and this is where we had a big, how do you say it, breakdown. After writing this, it's like nobody knew what to do. This is just basic fractions from elementary school. 3550 is numerator, 200 is denominator, and then we grab the calculator, and you get 17.75 goats, and which is impossible, so 17 goats. All right, because we can't really buy 0.75 goats alive. I guess you could if the poor little goat was missing legs, I guess, but that's kind of grim to think about. So here we go. You have $3,550, and you want to know how many chickens. So one chicken is $30. Once again, this is the setup because money over money is 1. And then you gather your numerators, you gather your denominators, right? And that's how you have 3550 divided by 30 chicken. Right, so what's that? 3550 divided by 30, and I totally made up these numbers. It says 118.3 repeating chickens, so we'll go with 118 chickens. Okay. I think here when I was trying to change the problem so that it wouldn't be exactly like the one on the test, I kind of messed it up, but here we go. How many stones do you weigh if you're 140 pounds? Well, you start off with 140 pounds, right? And can we go from pounds to stones? Yes, yes we can. Right here, see? Now you just need to decide what part goes in the numerator, what part goes in the denominator. Well, since you want to cancel pounds, you want pounds to be in the denominator, right? So that's why 14 pounds goes here and 1 stone goes there. See? Pounds cancels pounds, and now you're left with stones. And now I'm silly because I want to have these in different colors. Those are the numerators. That's the denominators. And so that means this is 140 divided by 14 stones. Right? So that's what, 10 stones? It's kind of weird. What do you think? I could have asked you how many kilograms do you weigh if you're 140 pounds, right? So 140 pounds equals how many kilograms? So you start with 140 pounds, right? And you want to go from pounds to kilograms, so that means we have to use this one. Same deal, you have pounds. To get rid of pounds, pounds has to go on the bottom. So that's why 2.2 pounds, 1 kilogram. Right? Wait, we cancel the pounds. Now, think your numerators, think your denominators. Right? Gather your numbers. So you have 140 over 2.2. And 140 divided by 2.2 gives you 63.63, so about 63 pounds. I mean, about 63 kilograms, my bad. All right. What are like pairs or like terms? It's going to be same variable with the same exponents. which ones are like terms. So let me see. X squared. Who else? This one is x squared. That one is x squared. So those are like terms. How many are x cubed? None. So that's the only one. How many just have an x? This one. So those two are like terms. There's this one and that last one, which doesn't have any like terms, okay? So please make sure that you can recognize your like terms. All right, when adding, since there's nothing to distribute, we can pretty much ignore the parentheses since we're just adding, right? So we just got to find our like terms. This is x squared, and that one's x squared. Right? So 6x squared plus a negative 4x squared, that's just, right? 6 minus 4 is 2. So it gives us 2x squared, right? Then 3x. And once again, this is 3 minus 1, which is just 2, so plus 2x. And lastly, right, this is just negative 5 plus 2, which is negative 3. All right, here's another one. We do like terms. We're just going to go ahead and highlight the other ones. All right, so 10x plus 4x is 14x. Negative 3 plus negative 5 is negative 8. Subtracting. So the difference here is that you have to distribute the negative sign. It's like multiplying by negative 1. So then you have 7x squared plus 3x minus 5 minus 5x squared minus 6. And now you go fishing for like terms. Right, those are x squareds. 3x. Notice that that's the only 3x that we have. And then the constants. Alright, so 7 minus 5 is 2, so this is 2x squared plus 3x, and then minus 5 plus minus 6 is minus 11. Okay, same thing, it's subtraction, so you need to distribute the negative sign. Right, so you have 12x minus 3 minus 10x plus 5. And then find like terms. So 12 minus 10 is 2, so this is 2x. Negative 3 plus 5 is plus 2. Multiplying. All right, the only way we've done multiplication of binary binomials is by the area model. So set up your grid. You put the x and the 5 here, and you put the x and the negative 2 there. All right, and then you multiply x times x, 5 times x times negative 2, 5 times negative 2. All right, and then you ask yourself, are there any like terms? And the answer is yes. Those two are like terms, and these are not. Right, so your final answer is going to be x squared. What's 5x and negative 2x? That's just 3x. And then minus 10. Okay, same. Same thing here. There's only one way that I have shown you how to multiply. We haven't done the distributive mode yet, but we will. 2x, 3, and then x and 2. So now you multiply. This is 2x squared. It's 3x. 2x times 2 is 4x. 3 times 2 is 6. Now you ask yourself, are there any like terms? Are there always going to be like terms? No, as you found out on the test. Right? So here the answer is 2x squared plus 4x and 3x is going to be 7x and then plus x. All right, so now moving on to the next part. For the next 3 questions, we're going to answer all of these questions, okay? All right, so I have it right here. Try to zoom in a little bit. Oops, what did I do? There it is. All right, so our polynomial is 4x squared minus 3. And it says, what is the degree of 4x squared? Well, the exponent is 2, so the degree is going to be 2. What is the degree of negative 3? Negative 3 is a constant, so the degree is going to be 0. Degree of the polynomial, the highest degree is 2, so the polynomial has a degree of 2. What is the name based on the degree? What do we call a polynomial that has a degree 2? Quadratic. E. How many terms do we have? We have 2 terms. What's the name based on the terms? That's easy. It's a binomial. List all of the coefficients. Well, only one of the terms has a variable, so there's only one coefficient, the number 4. F, G, H, the leading coefficient. That's the only variable, and so the leading coefficient is 4. I, is there a constant? Yes, there is a constant. What is it? The constant is negative 3. And what is the variable? The variable is x. All right, we'll ask the same questions for B. First, I'm going to write the letters. Alrighty, so for the degree of 4x squared, let's see the degree of the first term. The degree of the first term is going to be 2, because the exponent is 2. Then I wrote the degree of negative 3. How about the degree of the second term? The degree of the second term, right, we're looking at negative 3x. The variable is x, and we know that the exponent on the x is 1, so the degree is 1. Letter C, so the highest degree is 2, so the degree of the whole polynomial is 2. Name based on the degree, well, degree 2 are known as quadratics. Letter E, how many terms? In this one we have 3 terms. F, name on based on terms, be a trinomial. G, list all the coefficients. Well, how many terms have variables? 2 of them, the first term and the second term. So the coefficients are going to be the numbers in front. The number in front is a 6, and there's also a negative 3. H, the leading coefficient. Out of these two terms that have variables, which one has the highest degree? The first one, so the leading coefficient is 6. Is there a constant? Yes. What is it? It's a positive 2 right here. What is the variable? Same thing, the variable is x. All right, I moved everything around. We're gonna work on polynomial C, but this time I only gave you x. And yes, this is a polynomial, okay? So what is the degree of the first term? There's only one term, this one. And so what's the exponent on it? 1. So the degree is 1. Degree of -3, degree of the second term. There is no second term, so no second term. So there is no degree. Letter C, degree of the polynomial. Well, the degree of the polynomial is the highest degree, which happens to be 1. So it's 1 as well. What do we call it based on its degree? Linear. Right, you go constant, linear, quadratic, cubic, quartic, quintic, nth degree. E, how many terms? There's only one term. Name based on terms, monomial. G, list the coefficients. Where there's only one term that has variables, the only term. What's the coefficient? The coefficient is the number in front. And since they didn't write anything, that doesn't mean that it's 0. It's an understood 1. Right? The identity property here. So it's got to be a 1. So G, the coefficients is 1. The actual number 1. And yes, there's only one, but this one actually has the value of 1. H, leading coefficient. Well, there's only one coefficient in front of a variable, I should say. So then it's 1. Is there a constant? No constant. And J, what is the variable? X. All right, so on this one. Okay, so in this case, it looks like our polynomial is 12. And yes, a number can be a polynomial, okay? Degree of the first term. Well, the first term is the only term, which is a 12, which is a constant, so the degree is 0. Degree of the second term, there is no second term. Degree of the polynomial, well, the highest degree is 0, so the polynomial is degree 0. How do we call something based upon degree 0? We call it a constant. How many terms? We have one term. The 12 is a term. Name based on the number of terms. One term means it's a monomial. G, list all of the coefficients. There are no coefficients. No coefficients, no coefficients because there are no variables. List the leading coefficient. There is no leading coefficient. I'm just going to put LC for leading coefficient, okay? Is there a constant? Yes. What is the constant? 12. What is the variable? No variable. Okie dokie. All right, I hope that's helpful. Will works as a waiter and makes money from tips and hourly pay for H hours worked. And so we have this expression, 10H plus 30. All right, so 10H plus 30 has to be the money that Will makes. All right, so this is the total money that Will made. All right, so then the question is, where did Will get the money from? Will got the money from tips and from hourly pay. For those of you that know, hourly pay means you're given a specific amount of money per hour. So let's say you're getting paid $20 an hour. If you work 1 hour, you get 20 bucks. You work 2 hours, you get 20 bucks. So, but in order to determine the hourly pay, you need the rate of how much you're going to get paid per hour. So the only things, and you need to multiply that by age, the number of hours that you worked. So from here, it looks like this is 10 times age. So this is going to be the hourly pay. In this one right here, 30 by itself, pretty constant. It's probably the money that Will made from tips. So what does the 10 means? 10 is the hourly rate. That's how much he makes per hour. H is the number of hours. When you multiply those two, you get the hourly pay. Hourly pay, you get the money made from working hourly. So $30 is the tips, and the whole thing, like I said, is the total amount of money that Will make from the hourly pay and the tips. Alrighty, here we go. All right, the first one, number of terms. There are 3 terms. 1, 2, 3. Which ones are the terms? Well, the first term is 5x squared. The next term is 3x. And the last term is -2. So there's 3 of them. List the coefficients. Only 2 of them have variables. Right? The first one has a variable, and the second one has a variable. The coefficient is going to be the number in front. So the number in front here is a 5, and the number in front here is a +3. So the coefficients are 5, and they're also 3. Variable is going to be x, and the constant here is -2. Alrighty, again, now this one only has one term. The term is -10x. What is the coefficient? Well, there is a coefficient because we have a variable. So in this case, right, that's the coefficient. That's the variable. Okay, the coefficient is going to be -10, and the variable is going to be x. And there are no constants. All right, the next example. We have how many terms? We have 2 terms. What are they? Well, the first term is x squared, and the next term is -x. The coefficients, well, both terms have variables, right? Here's the variable, here's the variable. And so what are the numbers in front? Right? Well, the number in front here is an understood 1, and the number here is an understood -1. So your coefficients are a +1 and a -1. The variable is x, and no constant. All right, the last example. How many terms do we have? 1. What's the term? 3. Any coefficients? None. Why? Because we don't have a variable. Can't have a coefficient without a variable, and the only constant is the 3. Whew. All right, you and your friends go bowling. In order to play, you get charged a flat fee and also an hourly rate for each lane rental. All right, so what does 8h plus 15 mean? Well, flat fee is usually like a constant. So in this case, this one is the flat fee. And there's an hourly rate for each lane rental. Right, so this has to be the hours that you bowl, and this is how much you pay per hour, right? So 8 is the money you paid per hour for renting the lanes, right? $15 is the flat fee. H is the hours that you bowl. And 8H. What happens when we multiply them? You get the total charge for all the hours that you bowled. The charge based on the hours you bowled. Something like that. Sounds good. All right.